Hi, hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to continue writing the CSI plugin that we have been writing in the previous videos. In this video, we are going to specifically implement NodeStageVolume RPC of the Node plugin. Now, if we talk about the workflow, we know that create volume RPC gets called first when we try to create a PVC resource in Kubernetes cluster, and that RPC actually provisions a volume in the cloud provider or storage provider, and then controller publish volume is called to attach that volume to a specific node. And then if node plugin advertises that it supports staging and unstaging of the volume, in that case node stage volume is called to actually mount that attached volume to a staging directory or a staging area, and then from staging area this volume is actually mounted so that it can be used by a pod. If you have confusion about this entire workload, I have talked about this thing in much more detail in one of the previous videos in the same series, so I highly recommend you to watch those videos. Now let's go ahead and try to open the source code. So this is the repo where we have pushed the entire source code. So if you want to check that out, you can obviously check that out as well. And I just opened the source code that we have locally, and before actually trying to implement anything, let's just go ahead and try to understand all the things that we have already implemented. So we have already created a very skeleton of these two binaries that are node plugin and controller plugin. These two binaries or applications are going to implement some RPCs. We have also implemented some required or mandatory RPCs that are involved in creation of a volume, and then we have also created the respective Kubernetes manifests to actually get these things deployed on Kubernetes. And we have shown how the volume is provisioned in the storage provider as soon as the PVC is created, specifying the storage class. And the storage class that we are talking about here should mention the provisioner that we are developing. So all these things have already been done. We were already able to implement the controller publish volume in the previous video. And as soon as controller publish volume succeeds, in that case container orchestrator, in our case Kubernetes, is actually going to call NodeGetCapabilities to figure out if node plugin actually even supports NodeStageVolume or not. Because if we talk about CSI specification, NodeStageVolume is not mandatory RPC. If NodeGetCapabilities advertises that this particular node plugin supports NodeStageVolume, in that case container orchestrator is actually going to call NodeStageVolume. So first of all, let's go ahead and just try to add a log here that NodeGetCapabilities was called, just to see what are all the things that have already been implemented, and we would also see if NodeGetCapabilities is actually being called or not. So I already have a Kubernetes cluster, 3-node Kubernetes Kubernetes setup cluster, and let's go ahead and try to build this binary. So using this command, we were able to build the binary, and now we are going to build the container image. And the container image should be named, let's go ahead and try to see how are we naming these images. And I'm going to change the tag a bit and making it 13, and we also have to specify the context. So now if you see the image has been built, and let's go ahead and try to push it. So docker push, and then the image. Once the image has been pushed, we are also going to change the tag here. So since we have changed the code in Node plugin, we just have to change manifest of Node plugin. But in this particular case, just to make sure that nothing is going unexpected, we are going to change the manifest of both the plugins, controller plugin as well as Node plugin. Now, before actually deploying these things, what I'm going to do is, if you see here, we have a secret, and this is the secret that gets used to actually communicate with DigitalOcean APIs. So let me quickly go ahead and try to create this secret, because I deleted my previous token. So I am going to create the secret again, just generate the manifest, and I'm going to say create secret generic, and I'm going to change the token here. And now if you see that the access token has been updated, and you just have to make sure that in your case, if you are following through, you have correct access token in this particular secret. Now let's go ahead and try to deploy everything from manifests. And if you see here, it's going to deploy some RBAC related resources, a deployment, a daemon set for Node plugin, and a secret. Let's go ahead and follow the logs for the controller plugin as well as the Node plugin. So kubectl logs and labels of Node plugins pod is this. That is the reason I'm specifying the label here, so that we can see logs of both these pods. Okay, now we have already seen all these things in previous videos, so that is the reason I'm not explaining these things in much more detail. So now I'm going to create a pod and a PVC, and this PVC is going to use the storage class that we just created. If you see here, we have created a new storage class, and this is the storage class that this new PVC is going to use. Okay, so it created a pod and a PVC as well. And if you see, ControllerPublishVolume was created. So initially create volume was called, and then ControllerPublishVolume was called. And if you see here, NodeGetCapabilities was called as well. If you see here, we are able to see this log from the Node plugin that we have just added. So it simply means that, if I try to summarize everything once again, it simply means that we created a PVC. Let's go ahead and try to have a look into the PVC resource that we have. So we created a PVC, very simple PVC, specifying the new storage class that we have created along with our CSI plugin. And as soon as this PVC was created, a create volume request was sent to the CSI plugin or controller plugin, and then controller plugin actually issued the respective APIs to provision the volume on storage provider. And as soon as that request succeeded, container orchestrator again called ControllerPublishVolume to attach that volume to a specific node. And after that, if you see here, after that, NodeGetCapabilities was called to figure out if NodeStageVolume is actually supported by the Node plugin or not. So now what we are going to do is, we are actually going to specify in this RPC that NodeStageVolume is actually supported by this Node plugin. But before actually doing that, let's go ahead and try to observe how the file system in this machine looks like. So these are the three nodes that we have already seen, 3-node Kubernetes cluster. And if we look into the volume attachments, if you see here, this volume is attached to the node 1 Ubuntu, and this node 2, 02. So I am on node 02, and if we go to /dev and then disk, and then by ID, I should be able to see, if you see here, I am able to see the volume available as a block device, and or in other words, this particular volume is available as a block device at this particular path, or in other words, if you see, there is a symlink as well. So this is directly available in SDA, so /dev/SDA. So this is what we were able to do up until now. And if we also try to look into the output of df-h, if you see here, we don't see that /dev/SDA. If you see here /dev/ I'm saying /dev because if you see here, the symlink is created to // and by issuing // we got to /dev. So it simply means that there is a symlink to this block device to another file, that is /dev/SDA. And if you see here, by the output of df-h, /dev/SDA is not actually mounted anywhere. So these are the file system. These are all the file systems, and this is where they are mounted at. And we do not see /dev/SDA anywhere. But after NodeStageVolume, we should be able to see that device, the block device that is mounted, that is attached, is actually mounted to a particular staging area. So now let's go ahead and try to first of all specify that we support NodeStageVolume. So return, and we are going to return CSI.NodeGetCapabilities response, and I'm just going to leverage go def here. So it actually tells us what are all the fields in this particular type and things like that. So this is a slice of type node service capability. And if you see here, now we can specify that this particular node plugin actually supports stage and unstage of the volumes. So let's go ahead and try to figure out what we can specify there. So if you see here, stage unstage volume node service capability RPC type, and this is what we have to specify in the capability. So CSI dot node service capability RPC stage unstage volume, and by doing that we are advertising that this node plugin actually supports stage and unstage volume. So now what we are going to do is, now that we have specified that, let's go ahead and try to actually implement NodeStageVolume, because we know that immediately after ControllerPublishVolume was succeeded, and NodeGetCapabilities of Node plugin actually advertises that NodeStageVolume is supported. In that case, immediately after ControllerPublishVolume, NodeStageVolume is going to get called. So now we can assume that NodeStageVolume is called with this particular request. So before actually implementing this, let's go ahead and try to look into the NodeStageVolume request. What are the fields that we get, and then we can try to implement the RPC. So again, volume ID is the ID of the volume, very self-explanatory. Publish context, if you remember from the previous video where we implemented ControllerPublishVolume, if there is some extra information that you think would be needed by NodeStageVolume, and you want to you have that information while implementing ControllerPublishVolume, so you can set that information in a map, and that information would be available to NodeStageVolume in this particular field. Again, if I try to summarize, if you have some information while implementing ControllerPublishVolume and you think that information is going to be would be useful to NodeStageVolume, that information can be set to response of ControllerPublishVolume in a map, and that map would be available here in publish context field. Now, staging target path is, again, like the name suggests, is the staging directory, staging path, where we have to mount the block device that is attached to the node, or this is the staging area where the volume is going to be mounted at, and then eventually from this area the volume is going to be mounted inside a pod. So this is that staging target path, or in other words, this is the target path where we have to mount this particular device, let's say. Yeah, so that is the directory. This is the directory where we have to mount this particular block device. Now again, volume capability, we have talked about it a lot. It has some things, for example, let's say access type, access mode. It also has mount options and things like that. So yeah, you will have to basically figure things out from volume capability as well. Secrets is again a field, like the name suggests. If your calls, API calls, are going to need some secrets, you can get them using this particular field. And volume context, like publish context, volume context is the field where we get the details that we set from create volume RPC. So again, like publish context, if you are implementing create volume request, create volume RPC from controller plugin, and you think that there is some information that would be needed by NodeStageVolume, and if you have set that in the response of create volume, that would be available in the volume context field here. So now that we have talked about all these fields, and we also know that there are some of the fields that are required, there are some of the fields that are optional. So this is required, and volume capability is also required. So let's go ahead and try to at least verify these things. So verify or make sure all the required fields are present. So if request.volume ID is empty, in that case we have to return nil as response, and we also have to return error, and the error is going to be invalid argument because the request that we got is invalid, and the message is going to be volume ID must be present in the NodeStageVolume request. Similarly, we will also have to make sure that the other required fields are also present. So staging target path. So if it's empty, in that case again we'll have to return the response to be nil, and the error is going to be invalid arguments, and the message is going to be the same. So staging target path must be present in the NodeStageVolume request. And lastly, volume capability is also a required field, so we will have to verify that as well. So request.volume capability, and if this is nil, in that case we have to return a similar error. So status.error codes.invalid argument, and then volume capability must be present in the NodeStageVolume request. So now that we have verified these things, what we will have to do is we will have to first of all see if this volume request that was made was actually for block devices, or in other words, if the user who has created a volume request specified that they want the volume to be available as block device. In that case, if I try to explain these things once again. So I have already explained this, but if I try to repeat this once again. So let's say this is the volume that was created in the storage provider, and this volume was actually attached to the node. This is a Kubernetes node, and this attachment happened using ControllerPublishVolume request, and now this volume is available as a block device. So NodeStageVolume is actually going to mount this block device into a staging area. So this is the staging area where this block device is going to get mounted at. And then in the next step, that is NodePublishVolume, the volume will actually be available inside the workload from staging area. So if user has specified that they want this volume to be available as block device inside the pod or inside the workload, in that case we don't have to mount that volume in the staging area. What we can do is we will have to just directly mount that inside the pod as a block device. So if you see here, in that case there is no need to actually do anything in the NodeStageVolume request. So let's go ahead and try to check that. So if request dot volume capability dot access type, and if we try to figure out access type, and if the access type is actually block, in that case what we want to do is we don't actually want to do anything. So in that case we just return the response successfully, because if we don't return the response successfully, in that case call to this stage volume is going to fail, and then it's going to be retried. So that won't be a good solution, let's say. So that is the reason we are going to return the error to be nil, and then we are going to return empty response. And like I said, the reason is because user has specified that they want the volume to be available as block device in their workload. So there is no need to mount that in staging area and then make that available as file system in the workload or in the pod. So now that we have checked that, the other thing that we are going to do is we will also have to figure out. So again, if you remember, we know the target where we have to mount. If we look at this particular diagram once again, so we know this particular target where we have to mount the volume by staging target path, but we still have to figure out where the volume is actually attached. And if you remember, in the previous video we discussed that the volume gets attached at a particular file that has volume name in its name. So if we go back here again, by ID, and here this is the location where the volume is attached. And if you see here, most of the things are constant here, but this is the volume name that we need to get from the context that we have set from ControllerPublishVolume. So let's go ahead and try to do that. So we will have to figure out the source and target. So source is going to be, let's say, get path from volume name, and target is going to be request dot staging target path. And let's go ahead and try to implement this. So func get path from volume name, this is going to return string, and it also is going to take the volume name. So volume name string, and to pass volume name we will have to first figure out the volume name from the publish context. So if request.publishContext, and the key for which we have set the volume name can be figured out from this variable in driver.go. And again, if you are confused about this, I have already talked about these things in detail. That is the reason I'm not talking about these things in more detail. So if value comma OK equals to this, and if we did not find the volume name in the publish context, in that case again we are going to say that the request is not actually good. We don't have details, expected details in the request, so invalid argument, and volume name is not present in the publish context of request. And if the volume name is present, in that case we should actually store that in a string variable. So volume name is going to be val here, the value that we got from that publish context, and that is the volume name that we have to pass to get path from volume name. Now again, there are some advanced ways, or there are a lot of scenarios that I'm not handling here. I'm just trying to write a very minimum code using which we can get things working. But like I said, this is not production ready code. You will have to do a lot of refactoring, a lot of things to make this production ready. So I'm just going to return fmt.sprintf, and we know that the volume is attached at this particular location. So dev disk by id, and this path %s, and %s is going to be volume name that we figured out from publish context. So okay, now that we have source and target where we have to mount that volume, what we have to do is, let's go ahead and try to see a doc that I have already opened. So if you see here, when we try to add a new volume to droplet, it also recommends that format and mount the volume. And we have to do this because once we have the volume created, that volume doesn't have anything. It's a raw device, let's say. So in that case, we will have to make sure that there is a file system present in that raw volume that can be used by the applications. So that is the reason we will have to basically, let's say, format that partition, format that volume, and then create file system on it. And so that's what we have to do now. And if you see here, they have specified that when we try to create a file system, we will obviously have to specify which type of file system do we want to create. So let's go ahead and try to do that. So let's say we are going to say format the volume and create a file system on it. Now again, you will have to figure out which particular file system was requested by the user who created the volume request. So let's go ahead and try to do that. So request dot volume capability dot get mount, let's call it mount, and then mount.fs type. So by default, in the newer operating systems that we use these days, specifically Debian based distributions, the fs type is ext4. So by default, let's use ext4. But if mount.fs type is actually set, if mount.fs type is not equals to empty, in that case, what we are going to do is we are going to override fs type's value to mount dot fs type, and then so now that we have fs type that we want to create in a volume, let's go ahead and see how we can actually do that. So I also have another document opened here. It should be opened somewhere. I think I don't have that. So there is this command line tool called mkfs dot fs type. So again, it can be let's say ext3 or ext4 and things like that. So we are figuring out, that is the reason we are figuring out the fs type from the request, and because the command name actually depends on the file system that is that we want to create on a partition. So this is how the command is going to look like, and then we also specify the type, and the type is going to be the value of fs type that we got, and then we have to specify the volume where we want to actually, not volume but block device, where we want to create the partition. So in that case, it's going to be source. So this is the command that we have to basically run in order to format the volume and create the partition on it or file system on it. So now let's go ahead and try to actually figure out how we can use mkfs.fs type. So I already looked into this mkfs.ext4, and if I try to open this particular document, if you see here, it says the same thing basically is used to create ext2, 3, 4 file system, and I'm looking for the correct flag basically, because I don't think -t, I just looked at my notes and I don't think -t is the correct flag, and I think we have to use -f, and if you see here, it clearly says that force this particular utility to create a file system even if the specified device is not a partition on a block special device. So what we have to basically run is mkfs.fs type and then -f and then the block device, let's say. So in our case, it's going to be mkfs.ext4 -f and then /dev, etc. So let's call it format and make file system, and it should return an error, and it should take the source that we have to create file system on, and it should also take the fs type, and I think that's pretty much it. We got source, we got the fs type, and we would be able to basically create partition on it. So if error is not equals to nil, in that case return nil, and then status dot error codes dot invalid argument, and we are going to say fmt dot sprintf unable to create fs, error is this. Let's go ahead and try to print this as well. The reason is so that we can actually try to see these logs. We can actually see these logs in the Node plugin logs itself. Otherwise, we'll have to see kubelet logs. So format and make fs. It is going to accept source and then fs type string, and it is going to return an error. For now, I'm just going to return a nil, and it is going to be okay. So now what we have to do is we have to basically implement this format and make fs, and once that is done, what we can do is once we have formatted it, we will have to eventually mount this volume where we have created the file system to the staging area, that is target. So we have to implement another let's say utility. It's going to get called mount, and we will also have to check if error is not equals to nil. In that case we have to do the exact same thing. So fmt dot printf, hold on, return nil comma status dot error quotes dot invalid argument, and then fmt dot printf error percentage s mounting the source percentage s to target percentage s, and it's going to be error dot error source and then target. Just to remove the compilation error, I'm going to have a dummy implementation here. Return nil. Okay, so now what we are going to do is, let's go ahead and try to actually implement format and make fs. So we know that the command line tool looks like mkfs.ext4 or whatever the file system we want to create. So we are going to create the command first. So mkfs.cmd equals to fmt.printf, and it's going to be mkfs.%s, and %s is going to be fs type. Now we will also have to see if this particular utility is actually present where we are running this command or not, where this application is running or not, or in other words, whether this command is actually available in the node plugin controller or not. So if os dot or exec dot loop path, and the path is going to be mkfs.cmd. If you see here, loop path searches for an executable named file in the directories named by the path, and this is exactly what we have to do, and it returns string and an error. So underscore and an error. If error is not equals to nil, in that case we have to return fmt.errorf, and we are going to say unable to find the mkfs utility. Error is this. So mkfs command and then error dot error. So now that we know the mkfs.ext4 command line tool is actually available, what we have to do is we have to run mkfs.ext4-f and then source. So let's form this. So we know this is the command. We have to create another string slice, let's say, to have these values. So mkfs args, and it's going to be string, and the values are going to be -f, and then the source here is the source that we got from the caller, and we have to then actually execute this particular command with these flags or these options. So let's go ahead and try to do that. So exec.command, and command is mkfs command, and then args are mkfs args dot combined output. If you see here, combined output actually runs the command and returns its standard output, and it returns slice of byte out and error. So if error is not equals to nil, in that case what we are going to return with is, okay, so this is not going to be invalid argument. This should be internal, because we tried to do something and there was an internal error, and we are just going to return fmt.errorf, and we are going to say create part 8fs command failed, output is %s and error is %s out:_error.error. If this worked, it simply means that now we have created a partition in the block volume that was attached to the particular node. So now what we have to do is, now that we have actually created the file system successfully, let's go ahead and try to mount that. If we go back to this diagram once again, now that we have created partition, or sorry, file system ext4 by default, or the file system that user provided in this block device, now we have to actually mount this in the staging area. So we are going to pass, there are chances that we have some mount flags, mount options in the capability.get mount as well. So let's go ahead and try to figure them out. So mnt.mount flags is actually slice of string. So this is what we have to pass to mount. So we are going to pass source target, and we have to pass the additional argument as well. So mount flags and let's go ahead and try to implement this. So source and target is going to be string, and then mount flag is going to be a slice of string. So it's going to be options. And now what we have to do is, if you go here, and fortunately I have this document opened, if you look at mount, it just mounts a file system, and it says that mount -t type and device and directory, and this tells the kernel to attach the file system found on device. So this is going to be our source. If you remember in the previous step, when we formatted and made the file system in the device, that is what is going to be used as source here. So attach the file system found on device, we have created an ext4 file system on source at the directory dir. So this is exactly what we have to do. So let's go ahead and try to just maybe comment it here. And if you read the same document also says that the mount command is usually able to detect the file system, but it says usually. That is the reason we can specify that explicitly. So let's also specify fs type. Okay, so now that we have these things, like we created the mkfs command, and then we executed that, we are going to do the exact same thing. So mount command is going to be mount, and then what we have to do is we have to create another. We have to basically figure out if the target that has been specified is actually created or not, and if it's not created, in that case we will have to create that target. So if fs type is equals to empty, in that case we will obviously have to return fmt.errorf. fs type is not provided, and if fs type is provided, I don't think else is needed here, so we can just do this. But yeah, so if fs type is provided, in that case what we should do is we should actually create this particular directory, and we should then mount the source into that target. So let's go ahead and try to do that. So os dot make directory all, and it accepts path, so path is going to be target, and then permission is going to be 0 and once we have this particular call, it returns error. If error is not equals to nil, in that case what we are going to do is we are going to return the error %s creating the target directory, and we are also going to specify error here. Now that we have created the directory, what we are going to do is we are going to specify the fs type that we have here. So let's create a variable where we are going to basically hold all the flags to the mount command here, because if you remember, this is what we have to execute eventually. So mount args is going to be slice of string, and then we are going to add -t and type to this particular slice here. So mount args equals to append, and then -t and fs type. Now once we have done that, what we have to do is we have to append device directory, so source and target here. So mount args dot or equals to append source, and then the same thing, so mount args equals to append target. So now eventually again we will have to check for the options as well. Right now we know that we don't have any options, but check for options and then add them, append them at the end of the mount command. So we are not going to do this, maybe in the next video, but for now I think we are good. We have created the command, the exact same command that we want to execute, and now let's go ahead and try to run this command. So we are going to do the exact same thing. So exec dot command is going to be mount cmd, and then arg is going to be mount args dot combined output. It returns out an error. If error is not equals to nil, in that case we are going to say return fmp.errorf error %s mounting the source to directory to target. So error source and then target. Maybe we can specify the output here as well. So once we know that exec.command was successful, it simply means that now the block device is successfully mounted on the staging area, so we can return nil as error, and if error was nil, in that case we can just return the successful response. So CSI dot NodeStageVolume response, and I think this should work. So let's go ahead, and before actually running this, let's talk about what are the other changes that we will have to do in the deployment. So So we know that, let's say I'm talking about a particular node. So let's say we know that this is a particular Kubernetes node that we are talking about, and this particular volume that we have here, the volume that we have created using create volume request and attached it into the node using ControllerPublishVolume request. So let's say this is the volume that has been attached to this particular node. Now all this code that we have been writing here, this particular code is going to run inside a container, inside a pod on this particular node. So let's say we have this particular pod here, and this is the pod where our node plugin is going to run at. So if we try to run all these commands, we basically are trying to run two commands. One is to format this particular directory that we have here, or this particular device, so /dev/something, let's say. So one command is to actually format this and create a file system here, and the other one is to actually mount this inside the pod. So if we don't have, if the code is running inside this particular pod, in that case, how would someone be able to, how would this pod be able to actually format this particular directory? And that is the reason we will have to mount this particular directory inside the pod, or in other words, that is the reason we will have to mount this path from host, from the Kubernetes node inside the pod. I hope that makes sense. And once it's mounted, for example, if it's mounted at /dev as well inside the pod, in that case, if we run, for example, a command against /dev, that command, we can assume that that command is actually being run on the host itself. So that is the reason we will have to mount this volume inside the pod. Now, apart from this volume, we will have to mount another volume inside the pod, and that is the volume. So this volume should be basically, eventually, this volume should be available as in staging area, and let's say the staging area is var lib kubelets, etc., etc. So in that case, this is the target that our node plugin got. But again, if our node plugin that is running inside the pod doesn't have access to this directory, in that case, our node plugin, the command that is being run, mount -t source to direct source target, will not be able to do that. So that is the reason we will have to mount this particular volume as well inside the pod. So we have to mount two volumes, /dev and then var lib kubelet, because we know that var lib kubelet is the place where staging directory is actually configured, let's say, or where we have to stage this particular volume. So now let's go ahead and try to do these things. So let's open NodePlugin.yaml, and in NodePlugin.yaml we are going to create two more volumes. One is going to be named device directory, and the host path is going to be /dev, and the other is going to be, let's say, pods volumes directory, and the host path is going to be var lib and kubelet, because we know that this is where the fs of, yeah, we can talk about it in a bit more detail, but I don't want to confuse you. So that is the reason I'm saying, I'm going to say, let's say the volumes that are mounted to a workload are eventually available inside this directory, inside this parent directory. So that is the reason I'm going to mount this as well from host inside the pod. And we have to mount that in the node plugin, and we are going to device-dir, and device-dir should be mount path is going to be /dev itself, and then we also have to mount the other one, that is pods volume directory, and it should be mounted in this directory itself. Now that we have actually updated this manifest, again, if you are confused about this, just let me know. I would be more than happy to answer this in the comments. Let's go ahead, and if you see here, this is a very simple example of how a node plugin should look like. And if you see here, for the mount point directory var libkubelet, the mount propagation is bidirectional, and the reason is, again, if you try to read more about it in official Kubernetes documentation, there is a lot of information that you can read about. So I would recommend you to do that. But if I try to just explain it very briefly, once the volume is mounted inside a pod, if something happens inside the pod, those things should be reflected back in the host path. That is the reason we have to specify mount propagation to be bidirectional. Again, if you, like the name suggests, if something happens on host, the volume that is mounted, the host path, if you see here, again, so if something happens in the container, that should be reflected in the host path, and vice versa. That is the reason we have to use mount propagation to be bidirectional. So let's just copy that and paste that in the volume mount for var lib kubelet. Now that we have done that, I think the other very important thing that we have to do is, if you remember, like I said, all these things, the entire node plugin is going to run on this particular pod, and this pod basically is this particular Dockerfile. And if you see here, we don't have, I mean, Alpine by default don't have the mkfs.ext4, and that is the reason what we have to do is we have to install that explicitly. So let's search for that as well. So mkfs.ext4 on Alpine. And I think this is what we will have to do. So run apk add e2fs progs, and it actually installs all those utilities. So I think we are good now. Let's go ahead and try to test everything. But before that, yeah, so if you see here inside by id, we just have one block device, and using df-h, I also showed you that /dev/sda is actually not mounted anywhere. If I create another request, we are going to see another device here, and if NodeStageVolume worked successfully, we should be able to see that device mounted at somewhere. So let's go ahead and try to do that. But before doing that, let's delete this temporary thing that we have here. So delete -f manifests and tests. I'm trying to delete these stale resources just so that they do not interfere with the things that we are trying to do. Okay, so we still have to delete the PV. This is a hack. I would say you should not do this maybe, but I want to delete these things right now. That is the reason I'm doing this. Okay, we don't have PV, we don't have PVC, we don't have volume attachment. So we are good now. let's go ahead and try to build this entire thing once again. And docker build -t. Sorry about this. And I'm also going to change the tag. So now if you see, this utility is being added, and let's go ahead and try to push this, and we will also have to change the image here. We do not necessarily have to change controller plugin, but I'm just going to change it just to be safe. I'm going to apply everything once again. Okay, and yeah, this was expected actually. So it says bidirectional mount propagation is available only to privileged containers, and the other problem is device -dir is not found. So device -dir, and we also have to specify security context. So because if you see here, it says that bidirectional mount propagation is available only to privileged containers. So security context, and we are going to specify privileged to be true. Again, I'm just going to make things work. Maybe this would not be an ideal scenario for your production environments. So let's go ahead and try to create these things once again. So okay, there is unknown field privileged. So yeah, there seems to be a typo. PREVILE GD maybe. Okay, hold on. Sorry about this. Kubernetes privileged containers. Security context. Okay, I'm going to pause for a second. So I just checked my notes, and it looks like privileged is not actually allowed for spec.securityContext, but it's allowed for spec.containers*.securityContext. So let's go ahead and try to do that. So we just have to move this to the container that actually needs that privilege. Now I don't know the spelling, so LEGE. Okay, so let's go ahead and try to apply everything once again. And now if you see here, everything got applied successfully. And let's log the main pod controller plugin, and we are also going to log the things from node plugin. And like I said, we are doing this because we know that label in the node plugins pod is this, so that we can actually follow the log from both the pods. And I'm going to create the PBC and the pod now. So manifest and tests. Let's see. So ControllerPublishVolume, and after that we should see logs in node plugin. And if you see here, it says NodeGetCapabilities was called, and it looks like it did not like the response from NodeGetCapabilities because we do not even see. Okay, we don't have a log here, so we do not know even if NodeGetCapabilities, if there is a problem in here or in NodeStageVolume. Okay, so what we are going to do is, but just to show you, if I try to show you, we should be able to see not in the second node. If we get the volume attachment, now it's in third node, and if we go to dev desk by ID, we should be able to see, if you see here, we should be able to see a volume attached here. So at least that is done. And if we run df-h, okay, so it looks like things worked as expected. So if you see here, this volume was attached at this particular this particular device, and this particular device, again, this is /dev/sta, because I think I have explained it. If we go back by 2 directories, we get to /dev, and then /dev is actually, and /dev/sta, and if you see here, /dev/sta is actually mounted at this particular staging directory or staging area. So that simply means that our NodeStageVolume RPC worked successfully, and now we are able to see that this particular block device is successfully attached at this particular location, and we are able to verify that by running df-h command. And if we run df-h in the other node, if you see here, we don't see any mount for dev SDA, because this dev SDA was not actually mounted to any staging area. But in case of node 3, we are successfully able to see that /dev is mounted to this particular location. So yeah, I think this is the main thing that I wanted to talk about. But just to make sure that things are working perfectly fine, everything is working as expected, what I'm going to do is I'm just going to add a log in NodePublishVolume to verify that NodePublishVolume is actually getting called now. And if we look into this diagram again, NodePublishVolume actually mounts the volume from staging area inside the pod. So after NodeStageVolume, NodePublishVolume is called, and I'm going to just write a log here. So NodePublishVolume was called with source %s and target %s. So it's going to be context and request. So request dot target path, and then request dot staging target path. So staging target path is going to be source. I think you know this by now. And request dot target path is the target path where we have to mount this as part of NodePublishVolume. So let's go ahead and try to do this. So again, we have to clean up the things. So kubectl manifests and tests, and we have to build the application, and let's build it So it's going to be 15 and then push it. So let's change the image to be 15 in the controller plugin as well. And before applying everything once again, let's again clean up the thing. So delete all the PVCs forcefully, and then delete all the PVCs, and then delete all the volume attachments as well. Once we have done that, let's wait for this to get deleted. Okay. Sorry about this. We don't have a PV, we don't have a PVC, we don't have a volume attachment, so we are good now. So let's go ahead and try to apply everything once again, and we should get these pods running again. And let's log the controller plugin as well as the node plugin. And create a PVC and a pod, so manifests and test. So ControllerPublishVolume was called, and once it succeeds, NodeStageVolume is going to get called. Okay, so if you see here, NodePublishVolume was called with source. So this is the source where again we are going to verify this, and this is the target where we have to actually mount that volume. So NodePublishVolume is called. It simply means that NodeStageVolume was successful. And if we try to go ahead and if we look into, for example, let's say volume attachment, it says that this new volume is attached to 02, and if we get PVC, this is the PVC. This is the PVC name that we should see in the attachment. So this is the 02 node, and if you see here, we are able to see DF2 was created, and it's mounted, or this device is attached at /dev/sdb. And if we run df-h, we should be able to see that /dev/sdb is actually mounted at the staging area. So if you see here, /dev/sdb is actually mounted at this particular staging area. So yeah, I think, and now if I try to summarize these things once again. So what happened is, so we have this particular Kate's node, let's say, and we were able to create a volume successfully, and this volume was actually attached as a block device. So again, let's say this is how it was attached as a block device, let's say, inside the node. Now there are two steps to actually, in order to actually consume this block device inside a workload or inside a pod. And first step is actually staging this inside a directory, and then the second step is to actually mount that inside a pod. So again, I have talked about this in other videos. So as part of NodeStageVolume, what we were able to do is we were able to mount that in the staging directory, let's say. And now if we look into this particular log, if you see here, it says that source is this. So in this particular case, once NodePublishVolume is being called, sorry about my handwriting. So if NodePublishVolume is called, in that case, source is going to be this staging directory, and then target is going to be the directory where the volume is actually, where the volume should be mounted at. So yeah, I think this is pretty much it that I wanted to talk about. If you have any question about this, don't hesitate to reach out to me, ask them in the comments. Let me quickly check my notes to see if this is all that I wanted to talk about. Yeah, I think this was pretty much it. If you think that this is going to be helpful to one of your classmates, colleagues, share it with them. And thank you so much for watching. I'll see you in the next one.